As we have seen in compressible fluid flow, that is the formulas of velocity and mass flow rate, maximum velocity and maximum mass flow rate from a reservoir to a nozzle which is connected to the reservoir, and a compressible fluid is flowing from the reservoir to the atmosphere. So during this, we encounter certain kinds of changes, that is change in pressure as well as change in density. We'll apply all these equations to solve real life problems on compressible fluid flow through orifice and nozzle. So we have a problem over here which states that a large tank contains air at 28.44 Newton per centimeter gauge pressure. So gauge pressure is given to us. So we have to add atmospheric pressure and 24 degree Celsius. So T1 which is given to us and T1 that is 24 degree Celsius. The air flows through the tank to the atmosphere through an orifice. If the diameter of the orifice is equals to 20 millimeters, so D2 is given to us. We can calculate the value of A2, that is what we have got. Find the maximum flow rate of air. Take R is equals to 287 and gamma is equals to 1.4, atmospheric pressure is equals to 10.4. So all these things are given to us. So this is m dot max. So this is what we have to calculate. Now we should understand over here that it is from the orifice, it is exposed to the atmosphere. If it is exposed to the atmosphere, see, it is given to us, the air flows from the tank to the atmosphere. That means T2, that is the final pressure, is equals to the atmospheric pressure. So let us write down the data which we know over here. First, what is given to us is the gauge pressure P1. So P1 will be equals to P atmosphere plus P gauge 1. So this is 10.104. The gauge pressure is given to us as equals to 28.449 and both are given to us in Newton per centimeter square. So we'll multiply by 10 raised to 4 as Newton per meter square. So on calculation of this, we'll get this somewhat as 38.553 Newton per meter square, that is value of P1. So the value of P1 is given to us. Now next, what we have over here, we have to calculate what is the mass flow rate maximum. So in mass flow rate maximum, the formula which we have from our formula list, let us see what is maximum mass flow rate. We have written it previously as 0.685 A2 into P1 into rho 1. So let us write down this part, that is equals to 0.685 into A2 into P1 into rho 1. So over here we need value of A2, which we know from D2 is equals to 0.02 meters, which was initially given to us as 20 millimeters. A2 can be calculated over here. A2 is equals to, the value of A2 will be equals to pi by 4 into 0.02 square, that is equals to 0.000314 a meter square. So that is value of A2. Next thing, what is given to us is value of gamma, that is 1.4. Value of R is equals to 287 joules per kg Kelvin. The final pressure P2, which will be equals to atmospheric pressure. So this is 10.104 into 10 to power 4 Newton per meter square. So all these data is given to us. We have to calculate the value of M max. So we have A2, we have P1, we have to calculate the value of rho 1. That is quite easy now to calculate. We know that by ideal gas law, P1 upon rho 1 is equals to R into T1. So rho 1 will be equals to P1 into R into T1. So let us substitute the values over here. That is equals to 38.5 into 10 to power 4 upon R is 287. The temperature which we have not written, that was equals to T1 was equals to, from our problem, let us check that out. The temperature is 24 degrees Celsius. If you add 273 Kelvin, 24 degrees Celsius, 273 Kelvin if you add, so this comes out to be as 297 Kelvin. So this is 297. The density rho 1 after this calculation somewhat comes out to be as equals to 4.522 kg per meter cube. So we have calculated what is density. Now we can directly calculate the mass flow rate. So for mass flow rate, we know the formula as m dot is equals to 0.685 A2 into square root of P1 into rho 1. So this is 0.685 into A2, 0.000314 into square root of 38.5 into 10 raised to 4 and density as 4.522. On calculation of this entire part, we get this value as 0.284 kg per meter cube m dot. In the similar fashion in this problem also, we can calculate the maximum velocity. We know the equation of maximum velocity as V2 is equals to square root of 2 times gamma upon gamma plus 1 into P1 upon rho 1. We have all the values necessary for in this equation and we can calculate the value of V2. So I hope you have understood the entire module of compressible fluid flow through nozzles and orifices and the problems related to that, how to apply all the equations in calculating the variables. Thank you.